Camas. The Department of Ecology, David Knight, who Trevor mentioned, visited the plant and conducted an inspection and identified some issues that the state felt needed to be addressed. And in the facility plan, we revisited some of the industrial projections using the general sewer plan and comprehensive plan, growth rates for typical residential and commercial growth, so there's consistency among the city's planning documents, but we looked at a little more detail at the industrial discharges and what would be anticipated from those. And then, as we were developing the facility plan, the economy was starting to turn south, so there was increased focus on deferring large capital projects.
That increased on focusing, deferring large capital projects. Also, what comes with that, though, is that we move it out 5 or 10 years, and that 23.5 million becomes a lot larger number. Correct?
It does. Yeah. With inflation, certainly those costs grow over time. But I've got some slides that talk about the rate impacts and how referral can help you. So yes, that's absolutely yes. Yeah.
Could you review for all of us why it is we decided not to go with Camas? The more specific details in regards to hooking up with them?
Yeah, I can, I'll fill you in on what I remember, and then if Trevor wants to jump in on that. They were on a pretty aggressive schedule at the time, and it would have involved it was a significant, there would have been a significant cost to Washougal to partner in that. They were planning to build a thermal dryer that produces basically 90% dry solids, and they needed a decision from the city quicker, I believe, than Washougal was willing to move forward with that. It was a significant decision, and it wasn't a significant decision and a significant investment that Camas wanted an answer on more quickly than the city was comfortable making. There weren't strong indications that there were advantages that would make it worth making a decision like that.
They also had specific criteria for the composition of the sludge, which had to be thickened. Right now we're about 2.5, max 3%. It'd have to be a 17 to 18% cake, which we'd have to digest and then thicken. So that's another process we'd have to potentially invest in. And then contractually, whether it's a 5-year, 10-year, and opt-out, how sustainable it would be to go there long term. So,
was that the one that you're going to put a pipe from here to there?
Yeah, we talked about trucking and then piping, and all those alternates were looked at. There was actually a value engineering piece by Kennedy Jenks at that point.
So in the facility plan, some of the additional measures that we took to look at the needs of the treatment plant included doing condition assessment of the existing equipment and structures. There was a computer model developed for the biological treatment process. The model actually showed that the actual treatment capacity, and that this is a sophisticated model that's widely used in the industry, showed that the actual treatment capacity is greater than the permitted capacity. So that's something that the city could capitalize on in the future. However, the testing that you need to do to demonstrate to the state that that capacity is actually there requires you to have a redundant process. You can't push the one that you have to its limit when you don't have another one to rely on. So that's part of the issue with ecology. And then we did an in-depth analysis of biosolids alternatives. For all of these Class A treatment processes require that you digest or at least partially digest the solids, and then have an additional treatment step to provide to meet the Class A requirements. So we looked at things like thermal drying, like Camas is doing, composting, which you see in the middle, and the city actually, I believe, had a load of compost from Tacoma to demonstrate what the product is like, and it was very popular. And then we did a triple bottom line analysis that looked at social, economic, and environmental considerations of all of these options in selecting the recommendation, which was to go with the compost facility. So the recommended improvements that are in the current capital facility plan for the treatment plant have been developed through an iterative process with the Department of Ecology to address the things that they think are critical, provide the improvements that we feel and public works staff feel are necessary. And basically, what we've got is initially just a relatively minor improvement to address some capacity deficiencies in the UV disinfection system. And then a set of improvements in 2015 to 2016 that addresses the redundancy issue with the oxidation ditch, provides additional biological capacity, allows you to potentially take advantage of that capacity re-rating, and provide some of the associated equipment and site work to support that secondary process. Right on the heels of that, in 2017, is construction of the new biosolids facility along with the third secondary clarifier, and then finally 2018 through 2020 are the remainder of the improvements that are necessary through the facility planning horizon, including an outfall study and upgrade, a further expansion of the UV system, and then the new operations building and laboratory. So what this chart shows then are the different cash flow projections, starting with the original general sewer plan, what I've called the adjusted general sewer plan, which was the basis of some of the rate analysis that you saw last year by FCS Group, and then a cash flow based on that facility plan CIP that was in the previous slide. So like I said, the original general sewer plan had the 3 phases of improvements from 2007 to 2010. In the original rate model, those were pushed off a bit because obviously the headworks had been constructed, the other improvements hadn't been constructed, so those were pushed forward into the current planning horizon. And then the facility plan delays the bulk of the capital improvements beyond what was in that original rate model. And before we talk about the impacts of that, I just wanted to talk about some of the economic assumptions that are in the rate model. Obviously there are some assumptions that drive your costs, things like construction cost escalation, labor cost escalation, increased operating costs, and then there are also assumptions that drive revenue. The critical one that I wanted to point out being the composite customer growth rate of 0.25% in 2009 to 2010, 0.5% in 2011, and 2% thereafter. So one of the things that's important to understand is, the wastewater facility plan is based on growth projections from a comprehensive plan done back in 2006. The average annual growth rate, and that was 4%, which was a reasonable number at the time. But now, obviously, we're dealing with different conditions and different assumptions that went into the rate model, and that's one of the reasons that deferral of these capital improvements can be very helpful. So this shows some information that I think shouldn't be new to most of you. This is from a presentation in 2009 by FCS Group. Showed that based on the assumptions that were used in that model, that the cumulative recommended rate increase to meet the revenue requirements was 150% through the year 2014. And this shows in some more